All right, we are ready for Chapter 1, 1.1. Notice the screen is black. The review section, it was green. So Chapter 1, I'll do black. And it just kind of keeps you reminded of what chapter you're in. Different colored backgrounds there. So hopefully this will help you. And first of all, what we're going to do is just do a real quick reminder of our XY axis. Now, you can call it many different things: the Cartesian plane, the XY axis, the Cartesian coordinate system, all different kinds of names, and I'm just going to call it the XY axis just because that comes out easier. And we have 4 different quadrants to this, and again, this is review, and those are my quadrants. Important to know that both numbers are positive there. X is negative there, Y is positive. X is negative, Y is positive, and X is positive, Y is negative. You'll need to know that, especially in trig, and you need to know that in this course right here. This is the origin. That's the point 0, 0. Both the X and the Y are called axes, A-X-E-X, or A-X-E-S. The y-axis is this one. The x-axis is this one. Anytime you go left or down on an axis, you're moving in a negative direction. Up or right, you're going in a positive direction. The x-axis, or the x piece, whenever you're naming a point on a graph, like 3, 4, the first number is the x-coordinate, the first coordinate, or the abscissa. Okay, any of those 3, but most of us just call it the x or the y. And the y is called the second coordinate, the y coordinate, or the ordinate. But I won't call them abscissa and ordinate. I don't know why they threw those in there. But anyway, example 1, just kind of look at that. They're just asking you to graph and label the points. You already know how to do that, or you would not be in this class. And we get down to that second part there, middle of page 59. It says solutions of equations. All right, so what they're doing in that first example, they're just giving you an equation. And they're asking if negative 5, 7 is a solution. Well, you put negative 5 in for x, you put 7 in for y, and does that answer equal negative 18? Whoops, there's a positive 2 times negative 15 plus 3 times 7. Does that equal 18? Negative 5 plus 21 equals 18. It does not, so negative 5, 7 is not a solution. But when you throw in 3, 4, which is the B part of that, you'll find out that, yes, it is a solution. So that's all they're doing in that section there. You have got, when you have, let me get a graph on here. Let me just draw one here. I need to import a picture of one so it looks better. And you've got a line. So when the line crosses the y-axis, it's called the y-intercept. When it crosses the x-axis, it's called the x-intercept. It's also called, when it crosses the x-axis, the root of the equation. Basically what that means is where it crosses the x-axis, that is the answer for x. So if you have 3x plus 4 equals 10, you solve for x. If you were to graph it, whatever that x value is you solved is where it crosses the x-axis. That's the root. Now, as we get further in the class, you'll find that there are more than one root to an answer sometimes, not all the time. So an x-intercept is where it crosses the x-axis, and a y-intercept is where it crosses the y. And let me put this back up here and tell you that the coordinate, the location of this point will always be 0 and then a number. Okay, because you didn't go over any x, but you went up y. Well, you went up 3. And this one here, your first number will show up, but your second number will always be a 0. So an x-intercept always has a y of 0. A y-intercept always has an x of 0. So if I were to graph 2x plus 3y equals 18, you could very, very easily just put in a 0 for x, and get that, and that tells you where it's going to cross the y-axis. You could put in a 0, for y, and this is going to tell me where it crosses the x-axis. And then you've got 2 points, you can draw your line, and you're good to go. Okay, so pretty nice, pretty easy to be able to do that. All right. What you normally do is find those 2 points and draw your line and get a graph, but it's also good to have a third point in there, because a third point will tell you if you did it right. Because let's say you did those 2 points and you found this point and this point, you drew that line and we're good to go. If you would have put in found a third point, maybe your third point was over here. Well, now you've got a little problem here, because connecting these do not give you a straight line. So one of these points is off. So what that third point does is, if it also lies on this line, then you're good to go. Everything is right. If it does not lie on the line, then one of these points is wrong and you need to go back and re-look. But when you just graph 2 points, I mean, you can always draw a line between 2 points and you think you got the right answer. But that third point is a check to make sure you have the right answer. So if you're interested in doing a third point, you might get any point in the whole wide world that you want to put in here. So let's say I put a 3 in here for x. And let's see, if x is 3, what's y? Okay, so if I put in 3 for x, my y is 4. So there's another point that I can graph to see if it's also on the line. If it is, then I'm good to go. If it's not, then I made a mistake somewhere. So that third point is always used as just as a check as you're going through and doing these problems, just to make sure you're doing things correctly. All right, let's jump up to example 4. When you're graphing some equations, the book says it's easier to solve for y and then find ordered pairs. So we've got 3x minus 5y equals negative 10. And if you remember, back in your olden days, you made a handy-dandy little graph like this, which we still use, just not as often. And we can put, first of all, we need to set this equal to something. So we can say that 3x equals 5y minus 10, and then we divide by 3. All right, so what we can do then is we can put any number in here for y. 0, 1, negative 2. And so then we just say, all right, we're going to use the first one. We're going to put 0 in for y. So that gives me 0 minus 10, negative 10 over 3. So when y is 0, x is negative 10 over 3. All right, so let's get rid of all this. I got rid of that other one. I should have left that there. What was it? X equals 5y minus 10 over 3. I think that's what I had. Okay, now let's plug 1 in for y. So 5 minus 10 is going to give me negative 5 over 3. All right, and let's put negative 2 in. So x equals negative 10 minus 10 is negative 20 over 3. And there's 3 points, and then I can graph. Okay, so really any of the equations that we're going to do right now, you can solve for one of the variables, just isolate it, get the x or the y, your choice, whatever's easiest, by itself. Make a table like this. Plug numbers in for the variable that's not by itself. Doesn't matter which ones. I usually like to use 0 and then smaller numbers, maybe one positive and one negative. Plug those numbers in for y and see what your x value is. And your x value goes here, here, and here, along with your y values, and then you can graph it. So again, going pretty fast here because this is old stuff that hopefully you have experience with. If you don't, you're probably not in the right class. All right, so we have what are called independent variables and dependent variables. Usually x is the independent variable, meaning it's independent of anything else. It can be any number in the whole wide world. So if we have 3x equals y, x is independent. X can be any number in the whole wide world. And then, so let's say we decide it's going to be 4. So what's my y value when x is 4? My y value is 12. So my x can be anything, but my y value is dependent on what I put in for x. So that's why the y value is usually called the dependent variable. Now they can switch around. The y can be independent and the x dependent, but for the most part, you use the x as the one that you put any number you want in, and the y variable then is the one that depends on what the x variable is. So just a little bit of stuff there, bottom of page 62. All right, going to example 5. They're asking us to graph that. Okay, so because it's a quadratic, it is not going to give me a straight line. All right, so what we're going to do is we're going to make a table of values. And let's just put 0 in for x. So we have 0 squared minus 9 times 0 minus 12. So my y value is negative 12. Let's put 10 in. That gives me 10 squared minus 9 times 10 minus 12. And that gives me, when I put 10 in, negative 2. Okay, and then let's put, we tried 0, let's put negative 1 in. So that gives me negative 1 squared minus 9 times negative 1 minus 12 gives me a negative 2. So then I take these 3 points, graph them here, 0, negative 12, 10, negative 2, and negative 1, negative 2. Okay, notice I do not have a straight line. I will not have a straight line because that's a quadratic. But it isn't enough to really tell me what this graph does. So I need to make a whole bunch more values, and I end up getting an image that kind of looks like that. All right, so that's what you're doing when you're given a quadratic. And now let's turn this video off and go to the B portion of it. We still have a little ways to go on here. So we'll hopefully make it in a B video and be done.